This question belongs to data structure subject and was asked in GATE CSE 1991. So the question states, consider a binary tree in the figure below. So we have been given a binary tree. Now we need to tell what structure is represented by the binary tree. Okay. So first of all, let me tell you what is a binary tree. A binary tree is a tree in which every node has at most two children. So see, here this node has two children, this node has two children, this node has one children, this node has zero children. So we have at most two children, every node has at most two children. So it is a binary tree. Now there can be various types of binary tree. First one is binary search tree, in which it is used for searching. As if we have a node x, then on the left everything less than x will be present, and on the right everything greater than x will be present. Then we can have heaps. Heaps can be either a min heap or a max heap, and we can have an AVL tree. AVL tree is a height balance tree, or we can have various other types of binary tree too, but these are common types. Now let us see what is this. Here we can easily observe that 1 is the minimum among all the values, yes. 5 is the minimum among this subtree, yes. 7 is the minimum among this subtree, yes. 13 is the minimum in this subtree, yes. 18 is the minimum in this subtree. 25 is the minimum in this subtree. Thus, we can easily conclude that we are having the minimum value on the top, and all the items which are below this are greater than, if this is x, all the items are greater than x in its subtree. Thus, we can see that it is a min heap. So this binary tree is a min heap. Okay. Now, let us see what is option B. So, option B says that give different steps for deleting the node with key 5 so that the structure is preserved. Okay, before doing this, let me tell you option C. As based on option C, we can easily solve option B. So option C says, outline a procedure in pseudocode to delete a arbitrary node from such a binary tree with n nodes that preserve the structures. What is the worst case time complexity? So it is basically asking us to write the pseudocode to delete an arbitrary node from a min heap. So how can we do this? So if we want to delete a particular node, so the step is, first of all, find that node. Find that node index. Actually, these are basically stored in an array. So it would be stored something like this: 1, 5, 18, 7, 13, 25, 20, then it would be 11, 9, 15, 17, 27. So we need to basically, if we are given a node value like 25, we need to find the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We need to find the index. So what's the complexity for finding the index? Either it can be order of n if we are not given the index, and if we are given the index, then there is no need of doing this step, so it will be order of 1. After we have found that index, let us suppose we want to delete 5. Then what we do is that replace node with last node, or we can write here, replace desired node with the last node. Let us suppose here we need to delete 5, so we will replace 5 with 27. Okay, then what we will do, we will just do delete desired node. So here now we will delete this 5. We will just remove this link. Now what we will do? We will do down heapify from desired node index. So which means from this index where 5 was present, from index 1 we will do down heapify. So how we will do down heapify? So in down heapify we will basically compare this with its left subtree and right subtree and move the minimum among the two up, swap it. Like minimum among 7 and 13 is 7. So we will swap 7 and 27. Now minimum among its children, which means minimum among 9 and 11 is 9. So we will swap 9 and 27. So this is the tree for option B. So the structure is preserved and this is the pseudocode down heapify. Now let us see the complexity. So we have done option A, the structure is min heap. We have deleted 5 and this is the output node after deletion. And the procedure, pseudocode, this is the pseudocode for option C. Now we need to tell the worst case complexity. Okay. For down heapify, what we are doing is that we are just checking through the height of the tree. So its complexity would be order of log n. Why log n? Log n because heaps are almost complete binary tree. Almost complete binary tree means all the levels will be completely filled except last level, and that too is filled from left to right. Okay, so its height is log n. Height of almost complete binary tree is log n, which means height of heap is log n. And if as we are searching in the height during heapify, so its complexity would be order of log n. So what is the total complexity? There can be two cases. If we are given just the value, like we have to delete, let us suppose 11, then we need to find 11. Complexity of finding 11 would be order of n. Then heapify complexity would be order of log n. So its complexity would be order of n. And if we are given an index, let us suppose index 3, then no need to find it. Then finding complexity would be order of 1 and heapify would be order of log n. So it would be order of log n. As here in this question we are given that an arbitrary node. So we can assume that we are just given a value and not an index. And here the replacing complexity is order of 1, can be neglected. Deleting complexity is order of 1, can be neglected. So the answer for this is order of n, or we can say if we are given an index, then order of log n. This is the tree for option 2 and min heap is the answer for option 1.